Okay, I want to remind you of a couple things with stoichiometry. So as far as that goes, we've talked about really two main problems. Kind of the simpler one is when you are starting off with moles of one thing, we'll call it A, and you're trying to figure out moles of another thing, we'll call that compound B. So if you're going from moles of one thing to moles of something else, all we're going to worry about are those coefficients. So coefficients, those are the numbers you find in front of the formulas after you've balanced a reaction. All right, so I'm not going to really spend any time on this video working on that. I want to work on with you on more the complicated one. And the more complicated one is when you are starting off with not with moles, but you're starting off with grams. So if you have grams of one thing, we'll call it A, and ask you about grams of somebody else in a reaction, you can't do that in one step. It takes 3 steps. So we're going to first go from grams to moles, and then we'll go from moles to moles, and then moles back to grams. Okay, now to work that out, again, the reason it takes 3 steps is because the coefficients only really work if you have a moles of something. So grams to moles, the way we do that is we use our periodic table. So the number on the periodic table, that's always how many grams equals 1 mole. Now once we do that, if we do that first step, then we're going to be exactly where we were in that simpler problem, right? Moles of one thing, the moles of something else. So that means we'll be using our coefficients to go from moles of one thing to moles of something else. And then once we get to moles of B, we'll go back to grams with our periodic table. So again, we'll add up those weights of those atoms off the periodic table. And whatever you get for that total, that's the number of grams that equals 1 mole. So you need to keep that part in mind, right? The number on the periodic table, right, G next to it, that's how many grams equals 1 mole. All right, with that, I'm going to do one example here, and it's going to be sort of a limiting reactant problem. Let me go ahead and flip over to that slide. Okay, we're going to do a little example again. This is a limiting reactant problem. The way I know that right away is if I read the question, it tells me if you start with, and actually there's a little typo in here, if you start with 20 grams of lead 2 nitrate and 10 grams of potassium iodide, how many grams of lead iodide would I make? So in this example, I'm given 2 amounts. So what that tells me is I'm going to have to do the calculations twice. So let's go ahead and see what numbers they're telling us again. So we have the weight of the lead nitrate, that's 20 grams. And I have the weight of the potassium iodide, that's 10 grams. And then they want me to solve for how much lead 2 iodide I'm going to make. So that's what we're looking for. So if it's a limiting reactant problem, we're going to have to go through the calculations twice. And after we go through them twice, we'll get 2 answers, and the right answer will be the lower one. Now, before I try to do all the calculations, one thing I'm going to do is I'm going to make sure I have all my conversion factors, right? So let me remind you again, what's the basic idea? Grams to moles, moles to moles, moles back to grams. So this is periodic table, coefficients, periodic table again. All right, so I need to know, it looks like the coefficients, that's one number. Oh, that's kind of messy. Hopefully you can see that. That's coefficients there. I need to know the coefficients. So it looks like to me I already have those coefficients. It looks like a balanced reaction, right? I see like a 2 here and all that. And I could double check that it's balanced, but I think it is. And then besides the coefficients, I also need to know, I'm going to need to know these weights off the periodic table. So before I try to get started with any of this math, I'm going to go ahead and add up the weights off the periodic table because I know I'm going to need them. So I'm going to add up, for example, 2 potassium iodides. Oh, I got to change this back. I misspoke there actually, just potassium iodide. So I meant to say that the 2 isn't going to affect us, right? So we're actually only adding up to, 1 potassium and 1 iodine. When you see that coefficient, that doesn't affect your weight off the periodic table. So I'm going to add up 1 potassium and 1 iodine. So again, if I look at the numbers underneath the symbols, when I add 1 potassium and 1 iodine together, the weight of that compound is 166. Now that 166, that's my conversion factor. Always, 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 when you add that number off on the periodic table, that's how many grams equals 1 mole. All right. Now I know I'm going to need the other weights too, right? The conversion factors are the numbers off the periodic table. Well, some of the ones we're going to use. So let me go ahead and do that for all of them. I'm also going to do it for the lead nitrate. So for the lead nitrate, I add up 1 lead, and then if you look, there's actually 2 nitrogens and 6 oxygens. So if I put that all together, the weight off the periodic table for lead 2 nitrate is going to add up to the lead and the 2 nitrogens and the 6 oxygens, 331.22 grams. Now when you add that all up, again, whatever you get, that's how many grams equals 1 mole. Same thing we learned about in a previous chapter. All right, now I know at some point I'm going to need the weight of that compound I'm asked for, like the compound we're solving for. So the lead iodide. So again, if I add up the 1 lead and the 2 iodines, when I put that together, the weight turns out to be 461 grams equals 1 mole. So when I've added these weights up, I have all my conversion factors now in front of me. So that might make it a little easier if I'm worried about getting mixed up. The other thing I have in front of me is sort of my general game plan. Grams to moles, periodic table. Moles to moles, coefficients. Moles back to grams, periodic table again. So I'm going to know what to do with these conversion factors based on looking at my units. So let's go through it one time, starting off with, I guess it doesn't really matter what order. We'll do the Ki one first. So for the Ki one, we're going to do 10 grams of Ki. And I know I've got to get to moles first because that's what my game plan tells me, grams to moles. So we'll put grams on the bottom. And my game plan also reminds me we're using the periodic table. So when we put grams on the bottom, that makes the 166 go on the bottom and the 1 mole go on top. All right, now that would be for the Ki. Now the next thing is to go from Ki to the compound I'm asked about. Moles of one thing to moles of another. That means we're using our coefficients. So I'm going to keep on going. I'm going to put Ki on the I on the bottom. I'm going to put lead iodide on top. Now the way we get that, the way we get from one compound to another again is the coefficients. So Ki is going to be on the bottom, so it cancels, right? So that means we have to put its coefficient on the bottom, which is, oh, that got a little messy there, a 2. And then we put the coefficient of what we're solving for on top. I'm trying to get to lead iodine, and it doesn't have a coefficient. Another way of saying that is that it's a 1. All right, now let's see where we're at. We've made our second hop. Grams to moles, moles to moles. So now we're going to go moles back to grams. So moles back to grams, we're going to use the weight off the periodic table of what I'm looking for. So in other words, the lead iodine. I have moles of lead iodine here. Put moles of lead iodine on the bottom. And looking at our conversion factor, that means 1 goes on the bottom, 461 has to go on top. So I think it should look like that. Now if you work it out, the right answer to this should be 13.9. 13.90 of lead iodine. Oh, I should have written lead iodine here maybe. That would make it a little easier for you to see how the units work. Okay. All right. So with that, let's go ahead and get on to our second one. So for our second one, we're going to do the same thing. Could have written Ki here as well, just to make it a little clearer. All right, so I'm going to do it all again, but starting off with the 20 grams of lead nitrate. So we'll go through the same steps, grams to moles, moles to moles, moles back to grams. But this time I'm starting off with the lead nitrate, right? We got to do the work twice. All right, 20 grams of lead nitrate. I'm trying to get to grams of potassium nitrate. All right, so I'm gonna put this down here because I think I wrote over my picture there. All right, so grams of one thing to grams of something else. Periodic table will be our first step. Coefficients will be our second step. Periodic table again will be our last step. All right, so this time we're starting with lead nitrate. So its periodic table weight was 331. Look at my units. Where that going to go? Bottom. So grams cancels. All right, I could use a little more room, but we're going to squeeze it in here. All right, and then looking at my conversion factor, since I put grams on the bottom, the 1 mole has to go on top. All right, yeah, I wish I could add a little more room on this screen, but hopefully it's not going to be too messy. Okay, now right now, grams cancels. So I have moles of lead nitrate. So now we're going to go from moles of one thing to moles of the other. Coefficients time. So we'll put the lead nitrate on the bottom and its coefficient. So its coefficient, oh, it's a 1. I'm looking at the reaction. And then we'll put the coefficient of what I'm solving for on top, which is also a 1. That's the potassium, the lead iodine, I should say. All right. So now let's see again where we're at. Moles of nitrate would cancel, lead nitrate. So now we're going to keep on going from moles of lead iodine to grams of it. And you'll see again, it's the same last step. And actually, it's the same compound. So we'll be using the same weight. Lead nitrate goes on the bottom. 1 mole of it. That's the weight off the periodic table. And then on top, we'll put the 461. And if you work it out, it works out to be 27.8. All right. And how much are we really going to make? It's the lesser amount. So it would be the right answer would be the amount we would actually make, which would actually be the first answer we came up with. All right, so I hope that helps you out. So in this video, I just wanted to point out to you, if you're getting a little mixed up, I think the things that'll help you the most is keep that diagram in front of you, grams to moles, moles to moles, moles back to grams. And the other thing that might help you is kind of game out or make sure you realize what your conversion factors will be. So those are your coefficients, and then you're going to need the weights off the periodic table. So if you're stuck on where to start, at least add those up, and that'll maybe at least get you going on the right direction. Okay.